This is SpaceTime, Series 29, Episode 56, for broadcast on the 11th of May 2026. Coming up on SpaceTime, discovery of 27 new exoplanets, and they're all circumbinary worlds. In other words, they're like Tatooine. NASA's Mars Curiosity rover starts a new drilling campaign on the Red Planet, and the maiden flight for the Russian Federal Space Agency's new Soyuz 5 rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Well, we don't see them very often, but astronomers have just discovered 27 new circumbinary planetary candidates, that is, planets that orbit two stars, by using a new method to search for planets that would otherwise be difficult to find. So far, astronomers have discovered more than 6,000 extrasolar planets, that is, planets orbiting stars other than the Sun. The first 51 Pegasi was discovered way back in 1995. There are thousands more which have been identified and are just waiting to be confirmed. But until now, almost all of these exoplanets have been detected in single-star systems, like the one we're in. The problem is, most star systems are made up of multiple stars, such as our nearest stellar neighbour, Alpha Centauri, which is a triple-star system. Yet only 18 exoplanets have ever been detected in multiple star systems, including at least 2 and possibly 3 exoplanets in the Alpha Centauri system. And all that raises an interesting question. Is it a case of the more complex gravitational perturbations in multi-star systems preventing planets from forming or remaining in those systems, or is it simply due to observational bias because it's harder to detect a planet in a multi-star system? The most common ways of finding exoplanets are the transit method, gravitational microlensing, and the radial velocity method. The transit method involves light from a star being temporarily blocked out, as seen by an observer, due to a passing or transiting planet eclipsing that light. Gravitational microlensing involves the mass and gravitational field of a foreground star bending and magnifying the light from a more distant background star. That lensed background star's light can then be further magnified periodically by the added gravitational field and mass of a planet orbiting the foreground star. Then there's the radial velocity or wobble method. This involves a slight Doppler shift in a star's spectroscopic signature due to the ever so slight gravitational pull of an orbiting planet causing the host star to wobble ever so slightly. The new method, called apsidal precession, involves monitoring how binary stars are orbiting one another, which can be done by observing them when they eclipse each other. And that eclipse changes over long periods of time through precession. Now, if there's a variation in the normal rate of precession eclipse, which can't be explained by general relativity or stellar interactions, it means a third object could be influencing the star's orbits, and that body could be a planet. Now, because the 27 newly discovered circumbinary planets were reported in the monthly notices of the Royal Astronomical Society on May the 4th, Star Wars Day, May the 4th be with you, the authors are playfully referring to them as Tatooine planets, after the homeworld of Luke Skywalker and the birthplace of Anakin Skywalker, aka Darth Vader. Apsidal precession has been used to characterize binary stars before, but not in a large-scale search for planets. The new findings were made using data from NASA's Transiting Exoplanet Survey satellite TESS, a space telescope launched in 2018 with the mission of searching for and confirming exoplanets. One of the study's authors, Ben Monte from the University of New South Wales, says that with more than half of all star systems being binary, astronomy has really only painted half the picture of planets so far, and the other half of the canvas remains completely blank. This new method helps astronomers detect planets that might otherwise have been missed, thereby helping to build science's understanding of the types of environments which can support planetary development. By learning more about the different types of planets, astronomers can better understand how planets form and evolve, especially in complex environments with more than just one star. Now, these 27 newly discovered planets are referred to as candidates for now. That's because the authors still need to confirm or deny their planetary status, and that'll require additional observations. The newly found planetary candidates range from objects that could be as small as the mass of Neptune up to ones that are 10 times the size of Jupiter. The closest is about 650 light-years away, and the furthest some 18,000 light-years distant. Monte says even though the candidates stretch across immense distances, they're still relatively close to our stellar neighbourhood. Monte says as the study found 27 planetary candidates out of some 1,590 binary systems observed, that suggests a rate of almost 2% of binary systems which could potentially host planets. And that implies there could potentially be thousands or tens of thousands of possible planets out there waiting to be found. Astronomers still have lots of questions about planetary formation in binary systems, and this new planet hunting method could help fill some of those knowledge gaps, including how common these planets are overall and whether or not they could be habitable. Monte says if circumbinary planets do turn out to be habitable, it means life could be anywhere. Next, the authors will be studying the spectra of these binary systems using the Anglo-Australian Telescope in far western New South Wales. Studying their spectra will help the authors rule out whether these bodies are in fact high-mass objects like stars, brown dwarfs, white dwarfs, or even black holes. In the meantime, Monte and colleagues are planning to apply the same planetary search method on a larger sample size, and they're running simulations to better understand how the planetary candidates form and how they're likely to evolve over time.
This is really exciting for us because there's not that many circumbinary planets that have been known before, and they've all been found via similar methods, particularly the transit method. And so in this case, these are mostly from Kepler, a few from TESS, but these are objects that are just lined up along our line of sight, so that we see the planet go in front of the two stars, blocks some of the light from each star in turn. It happens over and over, and so we can tease out how big the planet is and how far away from its star. This is great. We found thousands of planets this way around single stars, but in the context of circumbinary planets, the planets that go around two stars, now we need kind of two alignments. We need the stars to be lined up and the planet to be in that plane as well. So we can really only find these very flat systems, these ones that all orbit in the same plane, and we don't understand much about the overall architecture of these systems as a whole. Do we only see these because these are the only ones that exist? Or are we missing lots of ones that are tilted a little bit, where the planet goes around in a different axis than the stars? And so this is our first chance to try to start finding those planets instead by looking for a different method, looking at the actual gravitational perturbations on the stars instead of actually looking at the detection of the planet itself.
Yeah, for a long time there, I was getting very worried. Oh my, are we about to head for a three-body system? And I don't like those calculations at all. But you're using a method which sounds quite simple, really. You look at the two stars orbiting each other and you watch how they precess, and then you see if there's any change in that.
That's exactly right. And so this is something that's been used for a long time to understand triple star systems. The math is complicated, but the observation is actually very simple. That if you have three objects orbiting each other, two in an inner orbit and a third much further out, it causes the orbit of the inner system to shift in time. This happens in our solar system. Mercury and Earth precess because of Jupiter, for example. And so if you see that the orbit, the relative timing between the two primary eclipses and the secondary, so how long it takes the two stars to come around, is shifting a little bit, changing in time, that tells us that there's something else in the system. Now, there are other explanations for those. There's general relativity does the same thing, and tidal effects on the two stars can also change the orbit. But those we can really measure precisely. We know exactly how big those effects should be. And so if we see any extra precession beyond that, that tells us that there's a third body in the system. And so now really, for the first time, because of missions like Kepler and TESS, where we have super high precision and a long baseline, so TESS has been observing the same stars for 7 years now, we can start to tease out effects that are subtle enough to be caused not just by stellar triples, but by planets.
When we look at the nearest star system to our own, Alpha Centauri, it's a triple star system. We know there are two planets orbiting Proxima Centauri, but Proxima Centauri is a long way away from the Alpha Centauri AB double star system. And so this was easier to find. But we think there may be at least one planet orbiting around Alpha Centauri A.
Yeah, that's absolutely right. And it's slightly different there because those stars are still, A and B are closer to each other than Proxima is, but they're still decently separated. And so when we talk about the planets around Alpha Cen, those are not circumbinary, but they go around one star and then the other binary, or the binary companion goes around that system. So there's two types. We refer to them S-type and P-type for historical reasons. But essentially it's, do you go around two stars with the two stars in the middle, or does one go around the star and planet system? So slightly different architecture, but still lots of interesting questions about planet formation. And I'm involved in a project led by Sydney Uni called Ptolemy, which will launch soon. It's a small space telescope to try to look for more planets around Alpha Centauri by just measuring very, very precisely the distance between those two stars, A and B. If one of them has a planet around it, it will wobble back and forth because of that planet's gravity. And so we'd see the distance between those two stars subtly changing in time. So in the next couple of years, we should know the kind of candidate planets there. Are they actually real? And if there are any kind of Earth-sized 1AU planets, we should have the sensitivity to find those as well.
And that's really the next step, isn't it? Working out what these 27 candidate planets are likely to be, because they're all different distances and they're all different sizes.
That's right. So right now, what we have is that the precession is consistent with a planet-sized mass companion, but the size of the precession depends on how far away the planet is and how massive it is in a very predictable, regular way, but it means that there's a degeneracy there. So there's different solutions that would exist. And so for these, it could be, for the typical system that we're looking at, maybe it's a Jupiter mass planet at 1 AU, or a 5 Jupiter mass planet at 2 AU, or a kind of Neptune-sized planet at half an AU. And we can't separate those out right now, given the data that we have. But those would look very different in radial velocities. The Doppler shift from these over in orbit would look very different. And so we are right now doing a campaign to follow these up. We're starting with the AAT, the Anglo-Australian Telescope up in Coonabarabran, to do a kind of first vetting, make sure none of them have massive signals that you expect from a stellar mass third body. And then any that survive that, we go to the VLT, the Very Large Telescope in Chile, and we're following those up with HARPS and Espresso on the VLT, and HARPS is on the 4-meter telescope there, to really try to measure those masses precisely and figure out exactly what these planets look like. So the smallest one we have could be as small as Neptune, and we know that from the transiting circumbinary population, most circumbinary planets tend to be very, very close to that inner stability limit. So we expect that many of these will be close to our low mass estimates rather than our high mass estimates. So the smallest could be as small as Neptune, and in more time, as we get more data and become sensitive to smaller precession signals, hopefully we'll be able to get down into rocky planets as well. We also know that they're all going to be at least an AU away. They're not these kind of hot Jupiter planets. And we know certainly that in our solar system, giant planets out at a few AU have lots and lots of moons. It's very common to have many moons there. And so even if none of these planets are necessarily habitable, have surfaces even, it's very plausible to imagine that any of them could have moons.
Now, what would you like to do next? Would you like to find more of these planetary candidates? You want to firm up what you've got? You want to do both at once? What's the plan?
It's a little bit of both. So the first sample here, this 27 planet catalog, was from a kind of pilot study. It was our let's look at the low-hanging fruit, see what we can find, take the kind of 1,500 best, most characterizable binaries and tests, and see what we can do, and really demonstrate that the method works well. But TESS has observed tens of thousands of eclipsing binaries. And in the next few years, we're going to know of many, many more. LSST, the Rubin Observatory, has just begun operations. They expect they're going to find 25 million eclipsing binaries. And the Argus Observatory in the Northern Hemisphere from the Schmidt Observatory system is going to have a similar number. So we can really expand this to be 100, 1,000 times the samples that we currently have, and really start keying in on the distribution, not just individual planets, but what does the statistics look like of circumbinary planets? What is their mass distribution? How do they compare to the single star population? And that will really start telling us about how planets form in binary systems and how it's different than around single stars. So it's an exciting thing to be thinking about, to be working on, and we'll follow these up as well. So we've got both projects going on in our team right now.
It'll tell you what the universe really looks like in a way, won't it?
Absolutely.
That's Associate Professor Ben Monte from the University of New South Wales. And this is Space Time. Still to come, a new draw campaign for the Mars Curiosity rover on the Red Planet. And Roscosmos says its new next-generation Soyuz 5 rocket has completed a successful maiden flight. All that and more still to come on Space Time. NASA's Mars Curiosity rover has commenced a new drilling campaign at a site called Atacama in the Red Planet Scale crater. The 6-wheel car-sized mobile laboratory is targeting layered sulfate bedrock situated on the crater's 5.5 kilometre high central peak, Mount Sharp. It's the first such material the rover's encountered since departing the boxwork terrain we discussed last week. Mission managers are planning a 6 Martian Day or SOLS program around the drill site with 3 sols dedicated just to drilling alone. But drilling on the Red Planet isn't like drilling to put a picture hook in the wall. The work includes targeting a likely drill contact location, then using the alpha particle X-ray spectrometer to undertake a series of observations, while coordinated microscopic imager observations are also carried out under varying light conditions to determine any changes between the datasets. Meanwhile, Curiosity's Mastcam acquired stereo mosaics documenting the drill site, as well as investigating bedrock variations at a site called Kimsashata and characterising layering within a feature known as Paneri Butte. Now, all this was followed by the actual drill sequence, which included sample portion characterisation activities. The Mastcam also targeted several nearby features, including a laminated rock with an exposed edge which has been dubbed Queen of the Andes, a rock with polygonal fractures that was broken during a Rover drive-over, which has been named Caraco, and additional coverage of the drill target. Curiosity's also continued tracking atmospheric dust levels, studying cloud movements, and documenting local dust devil activity. And its ChemCam laser-based remote sensing instrument was set to autonomously select 2 targets for future analysis. Mission managers are now delivering a portion of the Atacama drill sample into the ChemIn instrument, which uses X-ray diffraction to identify a mineral's composition. Scientists want to compare the mineralogy of the layered sulfate unit at Atacama against results from the rover's previous drilling operations at the Mineral King site, some 160 metres lower down on the slopes of Mount Sharp. That should reveal how sulfate mineralogy varies across different elevations of the stratigraphic sequence the rover's been ascending. This is SpaceTime. Still to come, Russia's new next-generation launch vehicle, the Soyuz 5, successfully completes its maiden flight, and later in the science report, a new study warns that a third of Australians aren't getting enough sleep. All that and more still to come on SpaceTime. Russia's new next-generation launch vehicle, the Soyuz 5, has successfully completed its maiden flight. The Russian Federal Space Agency Roscosmos says the inaugural flight was launched from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan on a suborbital trajectory. The new 3-stage rocket is designed to replace the Ukrainian-built Zenit launch vehicle. They're no longer available to Moscow following the Kremlin's invasion of Ukraine. The Soyuz 5 is designed to compete directly against the new Vulcan Centaur rocket from the United States, the Ariane 6 from Europe, and China's Long March 5. It's capable of carrying payloads of up to 18 tons into low Earth orbit and 5 tons into higher geostationary transfer orbits. For the test flight, the vehicle's first stage fired for 2 minutes and 59 seconds, heading in a generally northwards direction. The second stage ignited prior to stage separation in a planned hot staging manoeuvre. 5 seconds after hot staging, the payload fairing separated successfully and the vehicle turned east in a so-called dogleg manoeuvre before finally splashing down as planned in the North Pacific Ocean. The booster's engine was cut off around 6.5 minutes into the flight, just short of orbital velocity, allowing it to begin its descent and re-entry into Earth's atmosphere. Roscosmos confirmed the flight went as scheduled, with the first and second stages working as planned and a mass and size mock-up payload delivered as planned on a suborbital trajectory. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has confirmed that nearly a third of Australian adults get far less than the recommended 7 hours sleep a night, with 18 to 34-year-olds the most sleep-deprived of all. The findings, reported in the journal Australian Psychologist, claims the key disruptors include late-night technology use, worry and stress, and an overactive mind, often unrecognised as a trait or problem. The authors also found that fewer than 1% of adults who suffer from clinical insomnia had received the recommended first-line treatment, cognitive behavioural therapy, with many unaware that effective non-medication treatments are out there. A Curtin University-led study has revealed the extraordinary biodiversity hidden deep in underwater canyons off the Western Australian Ningaloo coast. These include species previously undetected in the area, such as the elusive giant squid and others thought to be completely new to science. The findings are based on using environmental DNA, that's the genetic material naturally shed by animals into seawater. Scientists can use this to document which species live at these deep habitats without needing to actually see or capture them. You can read the study in full in the journal Environmental DNA. A new study claims that by the late Neolithic, the brains of domestic dogs had shrunk by some 46% compared to their wild wolf counterparts. The findings, reported in the journal The Royal Society Open Science, investigated casts of the skulls of 185 modern and 22 prehistoric dogs and wolves spanning some 35,000 years. They found the earliest proto-dogs actually had larger brains than their wolf relatives, probably a result of adapting to living alongside humans. But by 5,000 years ago, that increased brain size had reversed dramatically, and dogs' brains now are some 46% smaller than their wolf cousins. The authors think the smaller brains may have made dogs more alert and wary, essentially making them better guard dogs, so early owners may have selectively bred their dogs to emphasise these qualities, leading to tinier brains. A new study claims people who endorse authoritarian political ideologies are also more likely to believe in the paranormal. The findings, reported in the Journal of Social Psychology, show that those who relied heavily on intuitive thinking were far more likely to believe in the supernatural compared to those who were more objective and analytical in their way of looking at the world. The study involved 1,139 adults who were asked about their beliefs in topics which focused on concepts that violate basic scientific principles, such as mind reading, witchcraft, lucky charms, ghosts and astrology. Participants were also tested on how much they enjoy deep thinking and how much they rely on intuition. They found that people who relied heavily on intuitive thinking tended to have stronger paranormal beliefs, as do those who scored higher in authoritarianism and social dominance orientation. They assumed that a lack of analytical thinking was the primary reason individuals with authoritarian views leaned towards the paranormal. But instead, the results showed that authoritarian ideology and cognitive styles independently contributed to paranormal beliefs. The skeptic's Tim Mendham points out that this has already been evidenced by the interest in the supernatural displayed by leading figures in the Nazi Party, although he points out it's just as prevalent in the far left as the far right.
Yeah, SS and Hitler himself, actually. They were very interested in Nostradamus and people like that, and they were using it to try and encourage people. Actually, Nostradamus says we're going to win, which is probably why they lost. They were definitely into that sort of stuff, which is why I think partially this article went into the idea of authoritarianism. It did come from a German university. I'm not quite sure if that's meaningful or not. A lot of articles on psychology and sociology and things seem to have a lot of holes in them, or they don't think a lot about what they're doing. This one is not bad. It's from the Journal of Social Psychology, pretty well referenced and explained. And basically they were trying to see if people with an authoritarian bent or sort of a social dominance bent had a higher belief in paranormal phenomena. They did quite a large survey, and it seemed to be a well-structured survey. They covered a lot of aspects, trying to see one with sort of philosophical or political waywardness or sort of bent they had, and then also seeing how much sort of belief in various sort of paranormal things like witchcraft and lucky charms and ghosts, astrology, that sort of stuff. And they found a bit of a link that they admit that the correlation is moderate to weak, but very robust, which means it's not very good link, but it's a clear link. So, I mean, it's a bit of a strange outcome. I think they would actually had this high hopes of actually finding that authoritarian belief, which is they define also as a bit intuitive, was a stronger belief in paranormal than a belief which is evidence-based, proper critical thinking assessment, which is true, that people who do analyse these things tend not to believe so much. Saying it's a right-wing thing might be drawing a long bow, because I'm sure there are lots of far left, etc., who are equally intuitive, they're necessarily very logical. They also believe in sort of paranormal things. But the thing that comes out of it is I think that the thing that's sort of probably well known to skeptics is that if you think about something more clearly, do some proper assessment, not necessarily do your own research, but do a proper assessment of the claims and things, will be less inclined to believe them. Whereas if you're the sort of person who says, it feels good, it feels right for me, it seems okay, this person seems pretty convincing, that sort of thing, that you will tend to believe more in the paranormal.
The Germans are actually very good at looking at their own history and learning from it, something that I think others could probably take a message from.
The researchers here sort of admit that it's a pretty decent survey, fairly decent number of people involved, pretty comprehensive, quite a lot of barriers to sort of loose thinking, if you like. They did a lot of different ways of looking at the subject, but they would like the same thing to the other countries because they fear that there may be a psychological or a historical feeling that people are more right-wing in Germany than, say, they are in other countries. So what they say is that it's a shared desire for security and control, which tends to make people believe in the paranormal, and that's true everywhere, regardless of political belief or everything. Overall, what they did say was that disbelief in the paranormal was generally more common than belief, at least among the participants they had, which is good news for skeptics. You often get the news that the world's population is going sort of silly. Men, older individuals, and those with higher levels of education were less likely to believe. I think the higher education is the key issue there, because education does make you think, supposedly, and be critical about things. And if you do that through paranormal phenomena, then you're probably less likely to believe.
That's the skeptic's Tim Mendham, and this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from bytes.com.